for some of you was, it's not that you weren't trying to not do it, it's just that you kind of were a little confused on that with the H. Since we're on the topic of H, it's good to know what H is, not just H dot. H is equal to R cross NV. H is called the angular momentum. So there could be a problem where I just ask you to calculate the angular momentum. We have a couple computer Smith questions on that for different objects, projectiles, find the angular momentum. You'll get different answers depending on what point you calculate the angular momentum about. This equation right here that some of you can't see, at least not Sean, but the one I'm circling right there, does that work if I calculate the moments about any point, or does it only work if I calculate around the center of mass?
Center of mass. That works. No,
Any point.
any point.
That one works for any point. Okay? You can pick your point. And for a lot of you, you were picking any point. You were doing the moments about the back tire, the moments about the front tire, whatever you want.
You better put a Carver on the final. I'm really sad it's not Carver. I did so much
All
work
right.
for Carver.
Chapter 11. Different, or not chapter 11, topic 11. Circular motion and different coordinates. So, for circular motion, I'm going to put up a couple things that you, it's not brackets as vectors, just a couple things you just need to know from Physics 1 that I didn't even really cover too much. You just need to know. Okay, you need to know if I told you I had an object traveling in a circle at a steady speed, and I told you the radius of the circle, and I asked you to find the period, you need to know what the word period means. Period means the time it takes to go around once. So you need to be able to figure that out. One way you could do that, if something's traveling in circles in your mind, you can kind of take a piece of scissors, cut the path, stretch it out. You know it goes 2 pi r. And if it's moving at a steady speed, you can figure out how much time it would take. Some way or another, you should be able to figure out if something moves in a perfect circle, how much time it takes to go around. So as such, you should be a little familiar with the idea of period, with theta dot, which is how rapidly the angle is changing. Frequency, which is just 1 over the period. So frequency would be cycles per second. Period would be seconds per cycle. So that's just a little background for circular motion. And then we should be familiar with using different coordinates. So you might need to use, in fact you will need to use the r hat, theta hat, radial transverse coordinate system. So you definitely should be able to prove relationships for velocity and acceleration. Should be able to show where those come from. You should be able to manage using those for funny motions like a spiral. So we're not yet to number 12. Number 12 is going to be solid objects. But for number 11, you should be able to use those equations for objects that, or for a path that might not, but that might have a situation where r is changing. One example I gave on the last test was some kind of path looking like that. And is the distance r from the center, as the object moves along this path, is r a constant or not?
No.
R is not a constant. So therefore, r dot, r double dot, that stuff is not 0. So you can't, it's not, so I might give you one problem where you can't just make everything 0, which is often the case for chapter 12. For solid objects, a lot of stuff will be 0. So for this kind of problem, not everything is 0. One test question which I gave you that I think most of you got wrong was for this object traveling in this path. I had it moving at a steady velocity of 5 meters per second. Does it take more time to get from A to B, or more time to go from B to C?
B.
B to C.
If it's traveling at the same speed but went a further distance from B to C,
It's the
because the
same.
spiral was getting wider, right? Then it would take more time to go from B to C than from A to B. Because if you were to continue the spiral, it's looking like that, okay? So do you agree it's taking more time to get from B to C than from A to B?
Yes.
How many degrees did it change to go from A to B? How about from B to C? So let's say we try to figure out theta dot, and we're just trying to compare A to B versus B to C. Theta dot is going to be our change in theta over change in time. Now, you're right, it's technically d theta dt, but we're just trying to look at this so we can get an estimate. Is theta dot bigger from A to B or bigger from B to C? So in both cases, delta theta is 90 degrees. Which one took more time though, A to B or B to C?
B to C.
So which one is bigger, theta dot between A and B or theta dot from B to C?
A, B.
Okay, so because it went the same angle but in less time, theta dot is slowing down throughout this motion. Theta dot is how many angles, or what's the angle per second, how many degrees per second, or how many radians per second is this changing? So, for this particular motion, definitely it's going to have to be a situation where theta dot is decreasing. I think almost all of you put it's either a constant, maybe one or two of you put increasing, but a lot of you are thinking theta dot had to be a constant. So if the velocity was a constant, then the theta dot couldn't be a constant. All right, so that kind of question for item number 11. So I'll put handle problems like spirals, determine forces, and convert from r hat and theta hat into I hat and j. So those are all the kinds of problems I'm going to give you from topic 11. So for example, if you know information about the r hat direction, you should be able to take that something that's given to you in the r hat direction and split it up into an I hat and a j hat. Chapter 12, solid objects. This is the last topic of the semester. So if you're dealing with objects that are solid, you need to be able to derive that. You should be able to derive that. This, though, would be a 30-minute problem. Not because I'm expecting, if you knew exactly what to do, if you memorized it, it would take you 5 minutes. Okay, but if you had to think through it and kind of work some stuff out, that could potentially take 30 minutes.
So I say FE or FG?
FE, external.
External. What about the moment of inertia?
Well, the moment of inertia is in that formula there.
We need to
So
know
we'll
how
have to
to
say, be able to use I, find I, etc. So I is either the sum of Ri squared and Mi, or if you write that as an integral, it's the integral of R squared dm. So be able to calculate the moment of inertia as needed.
Say if we can't calculate the moment of inertia, can we just say that we're going to use a random moment of inertia and then continue on and finish the question?
Absolutely.
Okay.
So say I can't get the moment of inertia. I'm going to make it 7. Now, of course, that won't help you if the problem was show that the moment of inertia of the disk is 1/2 mr squared.
Yeah.
Then you can try Carnot's technique. It's equal sign mr squared.
similar.
The materials lab finals after this.
Yeah. I don't know.
Now, of course, for
I'm a major.
number 12, solve some problems involving solid objects. You can have a pulley where now I have to factor in the mass of the pulley itself, so that it's not, the mass of the pulley is no longer 0. I can have some piston problem. One problem I gave Edgardo recently. I had a beam and some tracks. Go ahead.
Yeah, I'm gonna send you an email here to tell you that.
Okay. So any solid object, so it goes into this type of problem, is an object that is rotating as well as moving. So this beam right there, that beam right there, they're both rotating. This one's rotating and moving, that one's only rotating. The piston, though, is only moving. This beam right here, if this wheel were moving to the right, this beam right here is rotating and moving. The end of a track excavator, or the excavator piece, that's swinging down. That would be moving and rotating. So solve problems involving rotation and motion, and I'm out of time to do any concrete examples with that right now. As you're studying, look through this list and see what can you do, what can't you do. Know what you can't do. That'll save you a lot of time and energy on the final. If you just know I can't do something, like if James says, I can't get moment of inertia, but I can do everything else, he won't waste time on the problem that has to do with moment of inertia. So know what you can do, know what you can't do. We'll stop there. Float money.
Nope.
I just started to erase this. If anyone wants to take a photo, you got it in your notes?